Day 18 of 90, and this one will save your production servers. Picture this: your Go microservice is humming along, then suddenly it vanishes. No error, no stack trace, just gone. The culprit? A panic inside a coroutine with nobody there to catch it. Today we master Go's defer, panic, and recover, the structured failure firewall that turns silent crashes into clean, logged events you can actually debug. Let's go. First, the mental model. A panic unwinds the stack, running every deferred call on the way up. If it reaches the top of that coroutine with no recover, the whole process dies. Here's the trap that bites everyone: panic does not cross coroutine boundaries. A recover in main never catches a panic from a coroutine you launched with Go do work. Each coroutine is its own island. If it can panic, it needs its own recover right there, on that island. Let's prove it with a worker pool. Launch 5 coroutines pulling jobs off a channel. In a naive pool, job 3 panics on bad input, and your entire service goes down. All 5 workers, gone. Now wrap each worker's loop body, defer func, if arc equals recover, arc equals nil, log, printf, \worker recovered, %v \r. Run it again. Job 3's panic is caught, that one job is abandoned, and the other 4 workers keep processing. One bad job no longer takes down the fleet. Now let's build the real prize: HTTP panic recovery middleware. The signature is func panic recovery. Next, HTTP handler, HTTP handler. Inside, return an HTTP.handlerFunc whose first line is a deferred closure. Start bare, defer func, if arc equals recover, arc equals nil, w.writeHeader, 500, then next.serve HTTP, w, r. Now a handler panic becomes a clean 500 instead of a dead process. Notice, Go's standard net/HTTP server already recovers per request, but rolling your own means you control the logging and the response. That control is the whole point. A 500 with no detail is useless at 3 a.m. So upgrade the recovery block. Capture the stack with runtime/debug_stack and emit a structured event, slog error, \panic recovered \err /stack string debug_stack \path /req a path. Now every panic lands in your logs as queryable JSON error value, full stack trace, and the request path that triggered it. You go from the service mysteriously restarted to handler X panicked on this exact input. That is the difference between guessing and knowing. Quick but critical gotcha: defer argument capture. In a CLI tool you write defer-fmt time since start to log elapsed time. It prints nearly 0. Why? Arguments to a deferred call are evaluated when defer runs, not when the function exits, so time since start is computed immediately. The fix: wrap it in a closure. Defer func, fmt time since start, evaluates at exit and reports the real duration. Direct call captures now, closure evaluates later. Remember that distinction. Last pattern, and it's beautiful, named return values plus defer. Consider a transaction helper, func with tx, db sql.db, fn func, sql.tx, error. That named error is the key. Begin the transaction, then defer a closure. If it recovers a panic or sees error equals nil, call tx rollback, otherwise tx commit. Because error is named, the deferred closure reads its final value after fn returns. One cleanup contract handles commit, rollback, and panic, no repeated error boilerplate at every return. Day 18 done. The takeaway: defer, panic, and recover aren't exceptions, they're a controlled failure boundary. Give every coroutine its own recover, log the stack, and let named returns own your cleanup. Subscribe for day 19.